So last class we are discussing. So this class we are going to discuss the chemical nature of enzymes. So before that, so let me revive the last class. So last class we have discussed that protein is a biological catalyst. So there we have discussed that why the mother nature has selected only the protein to be the biological catalyst. So with that background we are going to discuss, and we have also discussed the basic characteristics of enzymes. So what are the basic characteristics we have discussed? Enzymes are highly specific, enzymes are more in number, enzymes are having the active component of the enzyme is having the three-dimensional structure, and the enzymes are altered by changing temperature and pH. Okay. So with that background, we will move on to the general characteristics of enzymes. General characteristics of enzyme. Okay. General characteristics of enzyme. Okay. So first thing, as we have discussed here also, enzymes are highly specific. Enzymes are highly specific. So I am keep on telling enzymes are highly specific. What you have understood from that? Like how a particular lock, you know that lock, okay, and you have door lock, you have separate padlock, everything. So when you have to open the lock, what you have to do? You have to take only that particular key for that particular lock, right? That is the specificity. Okay. If you take another key, you can't open this lock. Or if you take this key to another lock, that can't be opened. Okay. So specificity means it can operate only on that particular reaction or that particular molecule. That is known as the specificity. As how a particular key can be opened by only a particular lock can be opened by a particular key. Similarly, an enzyme can act only on a particular reaction. They can catalyze only a particular reaction. Enzyme can catalyze only a particular reaction. So this is having the various types of specificity that we will discuss later. First, I will just list out the characteristics, then we will discuss one by one. Okay. So enzymes are highly specific. Okay. They may be specific to a particular molecule or to the group. They may be absolute specificity. They may be absolute specificity or group specificity. The enzyme can exhibit an absolute specificity or group specificity. So we will take it out later, like what is meant by absolute specificity and what is meant by group specificity. Remember that enzymes are highly specific. And second important thing is, when you define the catalyst, how do you define the catalyst? Catalyst is not used up by the reaction. So here also enzyme is reusable. Enzymes are reusable in a reaction. Reusable, that means once the reaction is completed. For example, you are having an enzyme and then you are having a substrate, and then like enzyme substrate complex is formed and then product is formed. So enzyme has come back to its original status and it is again reusable. Okay, enzymes are reusable. Enzymes are reusable. Okay, that means enzymes are not consumed in the reaction. They are not used up. So enzymes are not used up. They are reusable. That means enzyme does not exhaust like any other catalyst exhaust in the reaction. Okay, enzyme does not exhaust in the reaction. So enzymes is reusable. Second important point is enzymes is reusable, as is the definition of catalyst. Okay, and third important thing is enzymes will enzyme will speed up the rate of reaction, will speed up or enhance the rate of reaction. Okay. So third important quality of characteristics of enzyme is enzyme will speed up or enhance the rate of reaction. That means it will increase the rate of reaction. For example, if we want to convert a lipid, if you want to oxidize a lipid, okay, we want to oxidize a lipid, so it will take more than 4 to 6 hours. Remember, so like for example, it will regularly, if you go by combustion or something like that, it will take more than 20 hours. Okay, but enzymes can do it in 2 seconds. That is the beauty of enzymes. Okay, enzymes will enhance or speed up the rate of the reactions. Enzymes will enhance or speed up the rate of the reaction. Okay, and next, as we have discussed in the first class, so enzymes are the active component of enzymes. Active component of enzyme is having the three-dimensional structure. The active component of the enzyme is having the three-dimensional structure. That is, fully functional form of enzyme is always in the three-dimensional structure. That is your fully functional form. Fully functional form of enzyme. If the enzyme has to be functional, the particular component of the enzyme that is involved in the activity is always three-dimensional in structure. Okay, and this active component is known as the active site. Okay, active site. Okay, active site will be discussed in separate topic. Later we will discuss. Remember that active component of the enzyme is having the three-dimensional structure. The active component of the enzyme is having the three-dimensional structure. Okay, in other way we can tell that fully functional form of the enzyme is always three-dimensional structure. And this active component of the enzyme is known as the active site. So active site we will discuss later. Just I am giving a brief introduction. Okay. Next point what we have discussed is same thing applies here also. The enzymes are altered by changing temperature. Enzymes are altered by changing temperature and pH. Enzyme activity can be altered by, alter means modified. Altered means modified or changed. Okay. Enzyme will exhibit different activity at different temperature and different pH. So, enzyme activity can be changed or altered by or modified by changing the temperature and pH. If you change the temperature and pH, enzyme activity is changed. Enzyme activity is changed. Okay. Then, as we discussed earlier, enzymes are again the proteins. Enzymes are proteins. Except ribozyme. So they are RNA containing enzymes. Okay. So remember that enzymes are protein. Another important general characteristics of enzymes is enzymes are proteins. That means enzymes are, except the ribozyme, almost all the enzymes are proteins. Ribozymes are nothing but the group of enzymes which are containing the RNA as the functional group. So here only 4 or 5 enzymes are there which are where the RNA is used as a enzyme. Okay. And These are the general characteristics of enzyme. So we'll come back to the specificity. The most important characteristics of the enzyme is specificity. Okay, we have discussed. Specificity is a particular property of enzyme. Property of enzyme through which a particular enzyme catalyze only a particular reaction. A particular reaction. Okay. And we have discussed earlier the specificity may be absolute specificity or it may be group specificity. The specificity may be absolute specificity or it may be group specificity. Let us discuss what is meant by absolute specificity. What is meant by absolute? Absolute means only on particular molecule. Okay. These absolute specificity means only that molecule it will act upon. No other molecule it will bind. Okay. Enzyme will bind only to the particular molecule. Only to that particular molecule the enzyme will bind. Okay. So enzyme will bind only to that particular molecule and the molecule which binds is known as the substrate. Okay. So here for example phosphofructokinase. So this is an enzyme which will bind only to the fructose 6-phosphate. Okay, and it will convert them into 1,6-bisphosphate, bis-fructose phosphate. PFK. Okay. So this particular substrate it will bind and only it won't bind to this enzyme does not bind to any other molecule. It will bind only to the phosphofructokinase, that is fructose 6-phosphate. It will bind only to the fructose 6-phosphate. This is example of absolute specificity. That means only to that molecule it will go and bind. It won't bind to any other molecule. That is known as the absolute specificity. That is known as the absolute specificity. Okay. It won't bind like your lock and key. Only that particular key can be opened by that lock. Okay. It won't be opened by any other lock. That is known as the absolute specificity. Another one is that is group specificity. So group specificity means this particular enzyme will be binding only to a particular molecules which are having a particular functional group. Okay, so this here group specificity, it will bind to molecules which are having the particular functional group. For example, hexokinase. Okay, it will bind to the hexose sugars. Hexoses. For example, can you name some hexose sugars? Yes, glucose, fructose, like that. It can bind to glucose, it can bind to fructose, like that. So, particular functional group. So, group specificity means, so here these enzymes will bind to molecules which are having a particular functional group. So, functional group, particular functional group, only those, for example, some hexose group or amino group or hydroxyl group, like that. So, there will bind to here a group specificity. In the group specificity, the enzymes will bind only to the molecule. Enzymes will bind only to the molecules which are having a particular functional group. For example, exokinase. Exokinases can bind to glucose or it can bind to fructose and then it will phosphorylate them. For example, so exokinases. So you can have the glucose or it can have the fructose in here. So it will convert them into glucose phosphate or fructose phosphate. So it can bind to glucose or fructose, but in absolute specificity it will bind only to that particular molecule. Here, so it can bind to a group of molecules. Group of molecules which are having the same functional group. This is regarding the general characteristics of enzymes. Then one more thing, important thing I want to tell you. So when we talk about the enzyme, so enzyme will bind to substrate and it will form enzyme substrate complex, which is later will give rise to enzyme plus product. Substrate is nothing but the reactant of enzyme catalyzed reaction. Enzyme catalyzed reaction is known as substrate. Enzyme catalyzed reaction. So substrate is nothing but the reactant of an enzyme catalyzed reaction is known as the substrate. So what happens is enzyme binds to substrate and it will form enzyme substrate complex, and later it will release the product and the enzyme is again active to take up the new reaction, to mediate the new reaction. This is regarding the general characteristics of enzyme. So if you have any doubts regarding this, you can message me. Thank you.